Hello, welcome to the second day of our sequence and series unit. Today we're going to learn about arithmetic and geometric series. Now, today we have a slightly different problem than we had yesterday. Today we're going to talk about if each day you put the same amount of money in the sequence into the bank account. For example, on day 1 you put $7 in. On day 2 you put $10 in. On day 3 you put $13 in, and so on and so on. So now the problem yesterday was if this on day 1 you have $7, second day you have $10. Now we're inserting this amount into the bank each day. So the total for any given day is what we call a partial sum. A partial sum of an arithmetic series, because we're adding the same amount each time, it's given by 7 plus 10 plus 13 plus 16, and so on and so on. Now the partial sum of the first 4 days would be 7. Day 2 would be 17. Day 3 would be 30. Day 4 would be 46. Now how can we quickly find the 10th partial sum? We could keep adding these up, and it would be 7 plus 10 plus 13 plus 16 plus 19, all the way up to 34. However, that's not practical to add those up every time. So we're going to look for a new method. So if I take S of 10, which is the sum of the first 10 digits, and I take S of 10, which again is the sum of the first 10 digits, if I add those up, if I add this side, it would be S sub 10 times S of 10, which would be 2S sub 10. Now, if I add each of these, this would be, what, 41 plus 41 plus 41 plus 41, and so on and so on. And even this last one is plus 41. So what I did is I took the series and flipped it around, add the first term with the last term, ninth term with the first term, or the second term, and so on and so on. And then you had this long list of 41s. So now what this is really 10 times 41, and now I have to divide by 2 to find what the sum would be. So 10 times 41 is 410. Divide that by 2, and it should be 205. Now that's much easier than adding up all these terms, because here you have to find all the terms. Now let's look at a shortcut. Now 10 is the number of terms, so I can just say that that's n. We're going to multiply it by 41. 41 is my t sub 1 plus my t sub n. This case is t sub 10, and that's my t sub 1. We're going to divide that by 2, and that's going to be my s of, now I don't need a 10, I can just say s of n. That would be a nice formula we can use to find the sum. So now if we want to find the sum of the first 100 terms, what we need to first find is t sub 100. So we have to look at my arithmetic equation, which is my first term times my common difference times n minus 1, which if I plug in 100, that's going to be 7 plus 3 times 99. Now the answer to this is 304. So my t sub 100 is 304. So now if I want to find s of 100, I have to take my n, which is 100, multiply it by my t sub 1, which is 7, plus my t sub 100, which is 304, and divide that whole thing by 2. Well, 7 plus 304 is 311. If I multiply this, it would be 31,100 divided by 2. And this one, I don't even know if I should do this in my head. I did it on my calculator. 15,550. that's going to be the sum of the first 100 terms, or how much money you'd have in your bank account if you kept adding that same amount each day. All right, so this is our equation for an arithmetic series. Now remember, a series, we call it a series because we're adding up each term rather than having a comma between each term. All right, let's find S of 100 in this situation. First, we need to find T sub 100, which is going to be 53 plus, we're going up by 7 each time, times n minus 1. Oh, and our n here is 100. So 53 plus 7 times 99 is 746. So now to find S of 100, we're going to have 100 times my first term plus my last term, all divided by 2. So now it just becomes a calculator exercise. Hopefully my calculator is trustworthy on this one. 39,950 will be the sum of the first 100 numbers. Now let's look at a geometric series. Now you can remember, you can tell it's a series because we're adding rather than just having commas. Consider that this series. How do you know it's geometric? Well, we're multiplying by 3 to get our next term. Now let's find the sixth partial sum. We keep multiplying by 3, getting new values, and then we just add those numbers up. 7 plus 21 plus 63 plus 189 plus 567 plus 1701 gives us 2,548. That's pretty easy to add up. Now let's look for a method for finding this. So what I'm going to do is I'm going to start with my S of 6, my sum of my first 6 terms, and I'm going to multiply it by my common ratio, which is 3. So when I do that, I'll have 21 plus 63 plus, if I multiply this by 3, I get 189. This multiplied by 3 is 567. This multiplied by 3 is 1701. And 1701 multiplied by 3 is 5103. All right, now once we have those, let's subtract. Now, if I subtract, this would be S of 6 minus 3 S of 6. Now, this whole mess minus this whole mess. Well, 21 minus 21 will cancel out. 63 minus 63 will cancel out. 189 minus 189 would be 0. Those would equal 0. And those would equal 0. So what we have is 7 minus 5103. And another way to look at 5103 is if I actually multiplied it out, but for our general rule, it'll look a little bit easier if I don't multiply it out. So if I had S of 6 minus 3 S of 6 equals 7, and all of these, again, canceled out, minus 7 times 3 to the 6th power. Now this left side I can factor out an S of 6, leaving 1 minus 3. Over this side I can factor out a 7, leaving 1 minus 3 to the 6th. Now we divide by 1 minus 3, and S of 6 equals 7. It's 1 minus 3 to the 6th, all over 1 minus 3. Now, of course, we can simplify this 1 minus 3 on the bottom to be 2, but I'm going to keep it in this form so we can look and try to figure out how we can make a formula out of this. So if I would generalize this to S of n, 7 is my first term, and I'm going to take 1 minus my r value to the n power, because if this is 6, that's going to be 6. And I'm going to divide the whole thing by 1 minus 3, where 3 is my r. So this is how we get the formula for the sum of geometric series. S of n equals t1 times 1 minus r to the n over 1 minus r. Now, try to do this one on your own. So pause the video, do the best you can. Here we have to multiply by 36 divided by 27, which is 4/3. Now, a common mistake on this is to divide this on your calculator and just put 1.3. But 1.3 can quickly distort what the true answer would be. One thing that's nice about geometric series is we don't have to find the nth term. So if I want to find s of 15, we want to find the sum of the first 15 terms. I start with my first value, which is 27. I multiply by 1 minus my r value, which is 4/3, to the n power, which is 15, and divide it all by 1 minus 4/3. All right. So first I take 4/3 to the 15th power, and I'll do this one step at a time, 74.83-ish. And then 1 minus 4/3 is, this is like 3/3. 3/3 minus 4/3 is going to be negative 1/3. So now we have 27. 1 minus 74.83 is negative 73.83. And now multiply that numerator together. And then divide it by negative 1/3. And I'll get 5,980.3. So this is going to be the sum of the first 15 terms. All right, try this one. Find the partial sum of the first 18 terms. Here we're multiplying by 0.75. So sum of the first 18 terms is going to be my first term times 1 minus my r to the n, all divided by 1 minus my r. So 0.75 to the 18th is going to be 0.0056. One minus that answer almost doesn't do anything because we're multiplying 36 by 0.994. So I'm going to multiply that times 36, then divide by 0.25. And my answer is 143.188. That's the sum of the first 18 terms. Find the partial sum for this series. So if I take 16.5 divided by 21, I get 0.7857. 12 divided by 16.5 is 0.7272. So this is not a geometric series. Let's see if it's arithmetic. It's 21 minus 16.5, 4.5. Is 4.5 subtracted from this 12? Yes. So now that we know it's arithmetic, now we can use the equation s of 15 is equal to n times t sub 1 times the nth term all over 2. The n is 15. We know the first term is 21. We just need to find the nth term. So the 15th term is going to be 21 minus 4.5 times 15 minus 1. So 21 minus 4.5 times 14, that's negative 42. So 21 plus negative 42, because t sub 15 is negative 42. So 21 plus negative 42 is negative 21. So 15 times negative 21 divided by 2, there's supposed to be a negative there. So I get 157.5. So S of 15 is 157.5, and that's a negative 157.5. All right. Now here we're multiplying, or we're dividing this, or multiplying by negative 1/5, multiplying by negative 1/5, multiplying by negative 1/5. So this is a geometric series. Our R is negative 1/5. Our T sub 1 is 25. So if I want to find the sum of the first 10 terms, I take T sub 1, which is 25, times 1 minus my R, which is negative 1/5, to the n, which is 10th power. Divide this all by 1 minus negative 1/5. If I take negative 1/5 to the 10th power, I get a very small number, and if I take 1 minus that number, I'll get 0.999999. That's good enough. It's really close to 1. If I multiply it, and then when I do out the bottom, 1 minus a negative 1/5, that's 6/5, which I guess we could say that's 1.2. So if I take that divided by 6/5, my answer is 20.83. So that's the sum of the first 10 terms. All right, here's your homework for tonight. Good luck.